Hello, and welcome to Chapter 5, Section 7, Scatter Plots and Trend Lines. In this section, we will learn to write an equation of a trend line. Our essential understanding for this section is you can determine whether two sets of numerical data are related by graphing them as ordered pairs. If the two sets of data are related, you may be able to use a line to estimate or predict values. First, let's review a little bit about a scatter plot. A scatter plot is a graph that relates two different sets of data by displaying them as ordered pairs. In this section, we're also going to introduce the term correlation. Correlation refers to how strong of a relationship two sets of data have. So we have three examples from your book here. This first example would be called a positive correlation because as y increases, x increases. Another way to think about this is if perhaps I drew a line following the majority of the scatter plot points, that line would be going uphill from left to right. And slopes of lines that go uphill from left to right are positive. So this would be a positive correlation. The second example, as y decreases, x increases, this is known as a negative correlation. Again, the line that could be made up, the direction these scatter plot points are going, would be a downhill line or a line going downhill from left to right. And we know that's a negative slope. So we can kind of use slope and correlation together. They're not quite the same thing, but visually they do look a lot alike. And then the last example, sometimes two sets of data just may have no relationship or no connection to one another. So we would call this a no correlation, meaning they just don't have any relationship. So let's take a look at our first example. In this example, we're going to make a scatter plot of the following two sets of data. A little bit of a review, but let's see here. I have a table showing the number of bags of leaves that were raked in a certain amount of hours. And the way that we create a scatter plot is we treat one column as x and one column as y. If you don't remember, usually x comes first, so the column on the left will always be x. Or another way to think about it is your independent and dependent variables. Time is always the independent variable, so it will always be x. But anyway, each one of these is an ordered pair. So we need to make sure we graph them accordingly. So the first one would be 1 and 1.5. Notice that in the number of bags column, they're not perfect even numbers. Well, 4 is. But what this means is they're not going to be perfectly located on our graph, and that's where a trend line will come into place here in a little bit. But anyway, graphing these points, we have 1, 1.5, which would be right about here, 2, 2.2, 3, and 4, 4 and 4.7, 5 and 5.1. Now disregard this little line here that connected. But as we look here, is this linear? Well, it's not linear. It's not a straight line that would go through all 5 of them. However, what kind of correlation can we tell from this set of data? Well, we can tell that it is a positive correlation. So here's your first U-try problem. Complete it both in your notes and fill out the Google form below. All right, for this example, this is a completely different example with a different set of data. I've already gone ahead and plotted my points. We're going to talk about a trend line. Now, a trend line is a line that is used to generally represent the set of data. We can only use a trend line if we have a correlation, a positive or a negative correlation. Now, for this set of data, we have a positive correlation. This data is going uphill from left to right. Now, the way to draw a trend line is not very scientific. Ideally, what we're trying to do, we're trying to draw a line that gets as close to the data as possible. So while you see this line I've drawn here, this is one possible trend line, but you could be off slightly with your angle. I will say this, when you're drawing your trend line in your notes and in your assignment to come, make sure you do use a ruler because it's going to be very important to see where that line hits up with some of the other ordered pairs on your graph. Now, once you draw your trend line, your job will be to find an equation for that line, one that we can use to predict values both inside our data set and outside of our data set. So to do that, after we draw our trend line, we're going to have to find the rise and run, the slope. After finding the slope, since we already have at least one ordered pair, we can use point slope form, the equation point slope form, to help us come up with an equation for our line. So I'm going back to this very same example. I haven't changed it at all. But what we're going to do is we're going to write an equation for this line. Now, I drew this line myself. Notice it's not a perfect line. It doesn't touch all the points. It doesn't have to. This is a trend line. It may touch some points. It may not touch any points, but it's a line that gets as close down the middle as I can between the sets of data. What I have to do is I have to pick out points that I can use to come up with slope. The problem is I can't necessarily use the points I've already plotted because some of them just aren't on the line. So what I will tell you to do is find an intersection between the x and y axis lines where you can say that's definitely a point on that line. Now, using the line that I have here, it looks like this point on this line lines up pretty close with the intersection line. So this point would be 6, 5. Again, this was not in our data, but we were using the idea that trend lines will generally tell us where the data is going to be. We can say that that's a point. And then as I go down here, even though it's in the negative quadrant, we can still use it. Looks like way down here it would be 5, 5. It's almost off my screen. But -5, -5 would also be a point on this line. Now, we could use any point in between. The problem is, if I wanted to use this point right here, this point would be tough to tell where on the y-axis it is. Obviously, it would be -1 over, but is this -1.3 or is this -1.5? Because we don't know, it would lead our answer to be not as accurate. So I want to pick points on the line that line up exactly with the grid lines. Again, it may not be a point that's in your data. It may be, but it may not be. Now, after I have these 2 points, the reason I came up with these 2 points on my line is so I can find slope. And there are many different ways to find slope. I could use rise over run. I could use the point formula. I'm actually going to use rise over run since we have a graph in front of us. And to get from this point, -5, -5, to this point, 6, 5, I would have to go up 11 and over 10. So that makes my slope 11 over 10. And you're going to find with trend lines, your slope's probably not going to be a pretty number. It's probably not going to be 1 or 2 or -1 or -2. It's probably going to be a fraction or even a decimal. I suggest leaving it as a fraction. Now, we're going to continue showing our work, and it's important that I keep that slope, m equals 11 over 10, because I need to put it into the point slope form. And if you remember, point slope form is y minus y1 equals m times x minus x1. Now, I know what slope is. I already found that. It was right here. I'm trying to put a box around it. The thing is, I need one x and one y from the data. Well, I've carried over this table of our data because we're going to use one of these points. Doesn't matter which one. I'm just going to use the first one just because it's listed first. So if you remember a point slope form, we leave in the y and the x. That always stays in. So it just becomes y minus y1, which is our y coordinate from our ordered pair, which is 0.5, equals, instead of m, I'm going to write 11 over 10. In parentheses, x minus, instead of x1, it will be just the number 1. Now I'm done. I've come up with a formula, or with an equation that represents this line. And what we'll be able to use this equation for is we'll be able to predict or guess values that aren't even listed in our data for the future. So here's your second and final you try problem. Again, I hope you read the directions because it will tell you to take and use the graph from the first you try problem. And finally, if you want to learn more about the coqui frog, which is a indigenous frog to tropical areas like Hawaii and Puerto Rico and the Caribbean, I included a fun little link for you to listen to the interesting frog.